All right, I'm just doing an update on the Simple Fast Huff and Puff VFO stabilizers. Now, it's an uphill slog to play with one of these. First of all, it'll only do one band without switches and stuff. So in other words, if you're hoping to put a stabilizer on an oscillator that goes from, say, 3 megacycles to 7, it's not going to happen. What you can do is you can set it up to do each ham band with switches, plug-in modules, whatever you want to do. That's the first negative thing. Second thing is a lot of the information, like from Hans Summers and other ones on the internet. This is Hans Summers. This is a Dutch guy. Okay. And I made contact with a guy from Belgium, the Holy Grail guy. I found him. In other words, I think it goes this way. Yeah. In other words, what's the problem? Okay, first of all their math and all their values are for either 5 megacycles or I believe 9 megacycles. So it wouldn't be 80 meters, 40 meters. It's their own band. Now, the Holy Grail one guy, he's in, I believe he said Belgium. And what he did, which got me, was, here's one of his pages. His oscillator, he's running his oscillator up high. Normally you run an oscillator when you're doing 80 meters. You run it 455 higher than what you want, okay? And he's running his, I think it's 4.5937 higher, whatever it is. So it threw everything off. Now, on the input, several people use this 4060. The problem with the 4060 is it won't let you have the outputs that you'll need for 80 meters. Okay? It won't allow you to, there's dividers. This thing's really annoying today. Well, anyway, when you look at the outputs of the ripple counter, it's a 14-stage ripple counter, but it doesn't give you all 14 outputs. Okay? So you want to use the 74 HC 4040. That'll give you the outputs. Now, in my case, in order to do that, I had to add, real quick, I added a divide by 2 circuit because the output I need on the 4060 isn't there. Lower ones are there. And the other thing, too, is they're using more divides because their oscillator frequencies are higher than what we'd use in this country. So you got to go with less dividing circuits. Well, on the 4060, it won't let you have those. They're internal. You can't get those. And that's why I wasn't getting signal lock. Now, I want to tell you about signal lock. I got this set up. If you look at the scope, I don't know if you'll be able to see this, but let me get it in the frame. As I turn the frequency up and down within the range that it'll track, all right, you'll see that move. That actually moves up and down. Okay, I'm going back up. It's coming back up. Okay, that's how you know you're going to have locking. Okay, if you turn your circuit on, you put your scope on there, or a high impedance voltmeter, and you see the voltage on the output of the 2 capacitors, the center tap capacitors. If you see that just go up when you turn the circuit on, and you make adjustments and you never see it come down, it's not working. You're on the wrong output of the divide, and the divide circuit is at the very beginning. Here it is here. For some reason my camera's whiting out this morning. I don't know why, but in other words, your first divider coming in off your oscillator, which would be on this one, it's a 74 HC 4040. And this circuit is really annoying. What I do is I put about an hour every day on it, thinking about it and working on it. And I got it to lock. I got it to do everything it's going to do. And I'm telling you, first of all, the first thing to watch out for is they're using different frequencies. They're using different values. Okay? And then there's simulator programs that won't do the 80 meter band. So they have all this stuff that supports their frequencies in their country. And then you sort of get involved in it. And you're like, why isn't it working for 80 meters? Okay, I picked 80 meters, which is just say 3.5 megacycles to 4 megacycles. That's my favorite band. I'm able to achieve lock. Now, I also found out that if I leave my Franklin oscillator on for 20 minutes, it's damn close. It doesn't really drift. And that was the other thing. The Huff and Puff, high-speed Huff and Puff stabilizer is really meant for an oscillator that drifts really badly. So you put this circuit on it. Now, in my case, my Franklin oscillator, I've showed you the schematic. I did a rant on that circuit. Make sure you use a voltage regulator. That's a really good oscillator. But I wanted to see this thing work. Okay, and I stayed with it. I'm like, why don't I get a lock? Why doesn't this make any sense? And I went through it and I added some capacitors and I changed it, and I'm still not getting it. And then finally, the guy in from Belgium, the Holy Grail, I start reading everything over and over. And on his schematic, and not on a schematic, on one of the pictures, he has like not a scope readout. It would be the simulator output. He mentions he's running his oscillator for 4.5, whatever, 4.9 megacycles higher than what he actually going to get on the receiver. So in other words, if you're receiving 3.5 megacycles on his receiver, the oscillator is 3.5 plus his offset of 4.5 megacycles. So in other words, he's using totally different dividers and everything in order to achieve it. So you look at his schematics, you say, oh, all I need is to divide by this number and this and that and this oscillator, and then you do it, and you can't get lock. And after a while, and I was going backwards in my head. In other words, as the frequency was going lower, I was using more dividers, and you don't. You use less dividers off the main input signal. I was going in circles, but I just did this video. Hopefully, if you stumbled on some of this and you need a very good power supply, as far as regulation, you also want to put the scope on your hot of your power supply and look for any data that's running in your voltage. And if there is any data running any voltage, add some 0.1s across each chip. Make sure you have them there. You can also add, because they're CMOS, you can also add 100 microfarads across from ground to plus. Okay, the 0.1s, believe it or not, shunt out high frequency spikes, and a big capacitor like 100 microfarad cap, that just helps any what we call a circuit that pulls a lot of current, which would be that switching transistor, that transistor that switches the output by the double capacitor. That thing needs a lot of current, not a lot of current, but more than the CMOS chips. So get that right, and then all you're going to see is a line across the scope, and it's going to go up and down. That would be the output voltage of the center top of these two capacitors, and you'll see it hunt. When you turn the dial, it'll move up. As you go up in frequency, it goes up in voltage, and if you go down in frequency, I believe it goes down. Well, anyway, you figure it out. But I'm warning you, this circuit is super hard, and a lot of the information out there is for a different frequency range. And you start playing with these simulators and the math, and in this case, yeah, you're going to have to do the work, okay? I could give you what I use, but I'm not done yet. I just wanted to give you an update, and I want to tell you, I have a lot of hours in on this thing, and I did finally get it to lock. And it's, you know, it's the devil's in the details. You know, I found that website, and I Google it, and I could find it through the guy's call letter, but when he puts the call letter in, it doesn't find it on his Google in Belgium. A lot of weird things going on with this thing. And it's been an uphill battle, okay, of unproportional magnitude, plus my eyesight. I have a habit, after I do a soldering connection, I turn the soldering iron off without even realizing. It's just a habit. And then I go and put another wire on, I look over, the soldering iron's off. I'm making myself crazy with this thing. And it's because I'm older and I'm wearing out. And this thing's really hard. And what you get when you finally get this working isn't worth anything, okay? But I'm the type of person, I see a circuit, I see so many people redrawing it, putting their names on it and everything. I said, let me try this thing out. And I got it working. But that's what the output you're going to get at the center tap of those two output caps all right, is going to go up and down with the frequency, but only in the range that you have the circuit set for. Once you go out of range, it'll do it whatever it wants, and you only get lock within a 1 megacycle range. So in other words, if it went from 3 megacycles, it would go from 3 megacycles to 4. Okay, it would stay locked within that range at any frequency you set it for. Okay, I think that's it. Oh boy, that's it.